All right, gonna work on some trigonometric notation of complex numbers. I mean, how fun does that sound? You kidding me? Trigonometric notation of complex numbers. Let's do it. All right, first thing we're going to graph complex numbers. This is a very easy part of the day, and hopefully, well, I don't know if you'll like it, but hopefully you will. Instead of having an x and y axis when you're graphing complex numbers, you got what's called a real axis and an imaginary axis. Your traditional x is the real, and your y-axis is the imaginary. So when you see 3 plus 2i, it means you go 3 on your x, 2 on your y, and you just graph that point right there. That's 3 plus 2i. If you go negative 4 minus 5i, you go left negative 4 on your real axis, negative 5 on your imaginary axis, and there it is. And the last one says negative 1 plus 3i. You go negative 1 on the real, 3i on the imaginary, and that's all you have to do. So enjoy those. Those are really easy, I think. I think so. All right. The second thing we're doing is absolute value of a complex number, which we haven't hit on yet. Complex number is written like a plus bi, and to take the absolute value of it, all we're going to do is take the square root of the a squared plus the b squared. So we're not going to use the I, just the a and the b. We're going to square them both and add them up and take the square root. So we're going to do a couple examples here. First one says 3 plus 4i. So I'm going to do the absolute value. I should have written that first. Let me go back and do that. The absolute value of 3 plus 4i is the square root of 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16. That gives me 25. So the absolute value of that complex number is 5. The second one, what is the absolute value of negative 2 minus I? A lot of people look at that and go, oh, it's positive 2 plus I. No, it's not. You do the square root of the negative 2 squared, which is 4. The coefficient on the I is a negative 1. So if you square negative 1, it becomes positive 1. And if you add those together, you get 5. And that's it. That the square root of 5 is the absolute value of negative 2 minus I. It's Pythagorean theorem. Okay. Last thing here, trigonometric notation for complex numbers. So what we're going to do is we're going to take a complex number and write it in trig notation, which is what the title was today, by the way. But we had to get to where we are here before we can, had to teach you the other stuff first before you can do the notation. Because R, what you see right there, R stands for the absolute value of a plus bi. So we're going to put the absolute value first, then cosine of the angle that the number makes with the x-axis for both the sine and cosine. I just made that very long. I didn't need to. Okay, let's try a couple here. Find the trig notation for 1 plus I and 3 minus I. Okay, what I need first is R. Remember, R is just the absolute value. So I'm going to do 1 squared plus 1 squared. It's square root of 2. All right, so I'm going to do the square root of 2 in front. Cosine theta plus I sine theta. Now, here's the trick for finding theta. Remember tangent way back in the day? Tangent is y over x. Don't forget that. That's y. There's our x, except not the I. So what I'm going to do is I'm going to go second tangent on my calculator because I'm looking for the angle. Second tangent of 1 over 1, which is just 1. So if I do second tangent 1, messed that one up right there on my calculator. Give me just a second to fix it. Okay, second tangent 1, I get 45 degrees. And it is 45 degrees because it's in quadrant 1. Okay, they're both positive. So I'll go put cosine 45, sine 45. Guys, that's it. That's the trig form of 1 plus I. Okay, let's try the second one because it may be a little bit tougher, or maybe not. I don't know. Got to find R first. R, I'm going to try to change colors right there. There we go. 3 squared, which is 9, plus 1 squared, which is 1. So I get square root of 10. My R is square root of 10. So I'm going to go square root of 10, open my parentheses, cosine theta plus I sine theta. Just got to find the theta. And again, the way we find the theta is I'm going to go tangent theta is y over x. In this case, negative 1 over 3. Now, before I do that, think about where that point is. That's quadrant 4. Because there's a good chance your calculator's not going to give you a quadrant 4 answer. It will, but not the kind we want. So I'm going second tangent, negative 1/3, close, and I get this answer. I get theta is negative 18.4 degrees. All right, so I do not want to put a negative angle up here. So negative 18.4, what I'm going to do is I'm going to add that to 360 to get the coterminal one, or the one that makes it positive. And I got 341.6 degrees for both of them, 341.6 degrees. And that's how you do that, okay? But you got to watch the quadrants. That's the only difficult thing, and it's not difficult, but you just got to know what angle is in what quadrant before you write your angle down. All right, last thing. we're going to go backwards. This time they gave me the trig notation, and then we should find the standard notation. Okay, so I guess we can use our unit circle. Cosine of 120 degrees, that's one you should know. Everybody knows cosine of 120 is like negative 1/2. I sine, and if cosine of 120 is 1/2, that means sine of 120 is square root of 3 over 2. You know, just from the unit circle. So all I'm going to do to finish up here is I'm going to distribute this 2 in the front. Like 2 times negative 1/2 is negative 1. If I do 2 times the square root of 3 over 2, the 2's cancel, so I get I on 3. And guys, there it is. All right, there's the standard form. All right, all there is to it. We'll work on it tomorrow, and I will see you then. So, can't wait to see you.